Fundamental Theorem of Arithmetic. Every positive integer n greater than 1 can be represented only in exactly one way as a product of prime factors. So for example, we have 450. Let us write it as a product of prime factors. Well, 450 is equal to 45 times 10. And 45 is 5 times 9. This one is 5 times 9. And 9 is 3 squared. 10 is 5 times 2. Now applying your laws of exponent for 5 times 5, that becomes 5 squared. This is the prime factorization. This is the prime factorization of 450, and there is no other prime factorization of 450. You had been doing this since grade school, although this may not be the way you are writing out the complete factorization of an integer. This is what you did when you were in grade school. You are given 450, and your teachers told you to produce a factor 3. So 450 is equal to 2 times 225. 225 is equal to 9 times 25. 9 is equal to 3 times 3. And 25 is equal to 5 times 5. So this was how you produce the complete prime factorization of 450. So it turns out the fundamental theorem of arithmetic is something that you and I had been doing when we were in grade school. And so we shall no longer use the factor 3 to produce the complete factoring of an integer because it takes up so much space. So when we shall look for the complete factoring, complete factorization, prime factorization of an integer, we will just write it out as one line, okay? The fundamental theorem of arithmetic, and in particular the prime factors, the factoring that results when we produce the complete factoring of an integer, is going to help us reduce fractions to simplest form and simplest term. Because with factoring, we shall see the common factors. For example, 155 divided by 750. You must produce the complete factorization so that you can see what are the common factors. Well, 155 is equal to 5 times 31. 750 is 75 times 10. 75 is 3 times 25. 10 is 2 times 5. 25 is 5 squared. And so applying your laws of exponent, 5 squared times 5 is 5 cubed. 5 is a common factor. 5 divided by 5 cubed becomes 1 over 5 squared. And so in simplest form, 155 over 750 is equal to 31 over 2 times 3 times 25, which is 150. 51 over 343. So let us produce the complete prime factorization of 51 and 343. For 51, it's 3 times 17. For 343, it is 7 times 7 times 7. And so they have no common factors. And so it turns out that 51 over 343 is already in reduced form. 386 over 418, let us write this in its simplest form. 386 is equal to 2 times 193. 418 is equal to 2 times 11 times 19. 2 is a common factor. 2 divided by 2 is 1. And so we are left with 193 over 209. Equivalent fractions. Equal fractions with different denominators are called equivalent fractions. 5 over 8, and 15 over 24 are equivalent fractions. Why? Because 15 over 24 is equal to this, 3 times 5 over 3 times 8. 3 is a common factor. 3 divided by 3 is 1. 15 over 24 is 5 over 8. How to produce equivalent fractions? So this is what you do. You multiply your fraction by another fraction that is actually equal to 1. For example, 6 over 7 is equal to 6 over 7 times 3 over 3. 3 over 3 is just 1, and so it does not affect the value of 6 over 7. And so 6 times 3 is 18, 7 times 3 is 21. So 6 over 7 and 18 over 21 are equivalent fractions. How about 21 over 33? Let us multiply it by 2 over 2. 21 times 2 is 42. 23 times 2 is 46. 21 over 33 and 42 over 46 are equivalent fractions. Find a fraction which is equivalent to 3 over 7 and has a denominator of 28. It's something like this. 3 over 7 is equal to another fraction which is equal to a over 28. What should be the integer in a? Well, this is what we know. 7 times 4 is 28. Okay? So you will multiply 3 over 7 by 4 over 4. 4 over 4 is just 1. And so multiplying it to 3 over 7 does not change the value of 3 over 7. It will change only in appearance. So 3 times 4 is 12, and 7 times 4 is 28. So 3 over 7 and 12 over 28 are equivalent fractions. Produce a list of 3 fractions that are equivalent to 3/4. Well, we can multiply 2 over 2. And so that's going to be 3 times 2 is 6, 4 times 2 is 8. So 3 over 4 is equivalent to 6 over 8. Well, we can multiply 3 over 4 by 3 over 3. 3 times 3 is 9, 4 times 3 is 12. So 9 over 12 is equivalent to 3/4. And we can also multiply 4 over 4. And so these 3 fractions, 6 over 8, 9 over 12, 12 over 16, they differ only in appearance, but they are all equivalent to 3/4.